All right, happy Wednesday, everybody. I didn't quite get as far as I wanted to yesterday, so just wanted to have a little video so you can understand what we're doing when we are isolating the variable and using inverse operations. So the first question here, x plus 3 equals 5. And I love this visual of a balance board, right? We have x and then 3 more, so x plus 3 on the left side, and then 5 on the right side. And to find out the value of x, we need to isolate x on one side. It's called isolating the variable, so leaving the variable on one side. And the way we do that is we get rid of these blocks. We just take it off. So pretend that it's just gone there. One of them is just gone. Well, if I get rid of that one, it wouldn't be in balance unless I eliminate one from the other side. So now we have x plus 2 equals 4. Well, I can eliminate another one from this side and another one from this side, and I have x plus 1 equals 3. And then I have another one here and eliminate another one on the right side. And now I have x by itself. So the variable is isolated, it is by itself. And I have 2 on the other side. So we know from this equation that x equals 2. This x is equal to 2. How can we do that without drawing a balance board or actually weighing things out? Well, we can just use the subtraction property of equality. So, like we read yesterday, another way to solve an addition equation is to use inverse operations, which are operations that undo each other. It's the opposite thing that cancels the other one out. So when you solve an addition equation by subtracting the same number from each side, you're using the subtraction property of equality. So in this equation, x plus 4 equals 7, I need to eliminate this 4, this positive 4 from both sides. So I'm going to subtract 4 from this side of the equation. And if I subtract 4 from the left side of the equation, that means I need to subtract 4 from the right side of the equation. Everything has to be in balance. Whatever we do to one side, we have to do the exact same thing to the other side to keep the equation balanced, to keep that scale from tilting. So what happens when I subtract 4 from the left side of the equation? That's right. X plus 4 minus 4 is x plus 0. And another way to say x plus 0 is just to say x. So we have that 4 and that negative 4, positive 4 and negative 4 cancel each other out. So I'm left with x on the left side of the equation. And on the right side of the equation, I have a 7, and I'm going to take away 4 from that 7. And when I take away 4 from 7, I get 3. And does this work? We found out that x equals 3, and we can plug that in. We can, instead of x, we have, when we say blank plus 4 equals 7. And now we're saying that x equals 3. And is that true? Does 3 plus 4 equal 7? Yeah, definitely does. We can solve, it doesn't matter what side of the equation everything is on. If we have 8 equals x plus 3, what do we need to do? Yeah, we need to subtract the 3 from both sides of the equation. Let's move on to one of the harder ones over here. Yeah, let's solve this one together. So we have 3 and 3/4 plus m equals 7 and 1/2. And I want you to work on this one on your own as well. But what are we going to do to balance this out? These are not whole numbers, they're fractions, but we need to subtract 3 and 3/4 from this side of the equation, minus 3 and 3/4 on the left side of the equation. And if we're subtracting 3 and 3/4 from the left side of the equation, what do we need to subtract from the right side? The same thing. We have to do the same thing on the left as we do on the right. So we're going to subtract 3 and 3/4. And we are going to get on the left side, 3 and 3/4 minus 3 and 3/4 is going to be 0. And then we're going to bring down the m. So 0 plus m is the same as m. And then equals, well, now this one's a little bit harder, right? 7.5 minus 3 and 3/4. Well, I need to, first off, have create improper fractions from 7.5 and 3 and 3/4, right? So 7.5 minus 3 and 3/4 is the same as, well, 7 times 2 is 14. So I get 15 halves. So I'm going to have 15 halves. And I'm going to subtract from 15 halves 3 and 3/4. Well, 3 times 4 is 12. So we have 12/4 in 3 wholes. And I'm going to add 4, and I get 15/4. 15/4. So now I have halves on the left side and fourths on the right side. Well, 15 halves, we cannot subtract a fourth from a half, right? These have different denominators, so we need to change the denominator of 15 halves. And 15 halves is the same as what? It is the same as, just cross that off and make 30/4. 30/4 is the same as 15 halves. So now I have a common denominator, 15 halves and 15/4, both 15 halves is 30/4, and we have 15/4 on this side. Now we can just, so 30/4 minus 15/4 is 15/4. And 15/4 is equal to what? Yeah, it's equal to what we had in the beginning. So 7.5 minus 3 and 3/4 is 3 and 3/4. 3 and 3/4. Because 3 and 3/4 times 2 is 7.5. So it makes sense that the 3 and 3/4 would be our answer. 3 and 3/4 is the answer. M equals 3 and 3/4 because 3 and 3/4 plus 3 and 3/4 equals 7.5. All right, you've got one more to do there, and then a matching problem, and then exit ticket, and that's all you need to do today. Let's just go over one of the questions on the matching problem. You're going to need to use your pencil and paper to match these together, but I'm just going to find one of the easy ones. Let's see, if I had x plus 25 equals 75. X plus 25 equals 75. Well, I'm going to subtract 25 from the left side, and I get x. And I'm going to subtract 25 from the right side, and I get 50. So 75 minus 25 is 50. And I know that x equals 50 is a pair. There we go. Gave you one. You can work on the rest on your own.